Download this code from codegive.com, link in the description below. Quicksort algorithm, an informative tutorial. Quicksort is a highly efficient sorting algorithm that uses a divide and conquer strategy to sort elements. It is particularly known for its performance on average and its ability to sort in place, requiring minimal additional memory space. Overview of quicksort. 1. Divide. Choose a pivot element from the array. The choice of pivot can affect the performance of the algorithm. Common strategies include picking the first element, the last element, or a random element. 2. Conquer. Partition the array into two subarrays. Elements less than the pivot. Elements greater than the pivot. 3. Combine. Recursively apply the above steps to the subarrays. The base case for the recursion is when the subarray has one element or is empty, in which case it is already sorted. Key characteristics. Time complexity. Average case, O, n log n. Worst case, O, n superscript 2, occurs when the smallest or largest element is always chosen as the pivot. Space complexity, O, log n, due to recursive stack space. In place, yes, does not require additional storage apart from the input array. Stable, no, equal elements may not preserve their relative order. Steps in quicksort algorithm. 1. Choose a pivot, select an element from the array as a pivot. 2. Partitioning, rearrange the array so that all elements with values less than the pivot come before it, and all elements with values greater than the pivot come after it. 3. Recursive sorting, recursively apply the above steps to the subarrays. Code example in Python. Here's a Python implementation of the quicksort algorithm. Explanation of the code. 1. Function definition. The quick_sort function takes an array as input. 2. Base case. If the array's length is less than or equal to 1, it is returned as is, since it's already sorted. 3. Choosing the pivot. The last element of the array is chosen as the pivot. 4. Partitioning. Two lists, left and right, are created to hold elements less than and greater than the pivot, respectively. 5. Recursion. The function is called recursively on the left and right subarrays, and the sorted results are combined with the pivot in the middle. Conclusion. Quicksort is an efficient and widely used sorting algorithm that excels in performance for average cases. Understanding its divide and conquer approach can help in grasping more complex algorithms. With this implementation, you can sort any list of comparable elements efficiently. Feel free to experiment with different pivot strategies or implement optimizations like using the median of 3 method to improve performance in the worst case scenarios.